In this lesson, we are going to learn about how we calculate concentration. Concentration is the amount of solute that is in our solvent. So you have heard about the words concentrated and dilute. The word concentrated means that we have a lot of solute compared to solvent. The word dilute means we have a little bit of solute and a lot of solvent. Okay, so before we begin, I would like you to consider a solution. We have two solutions. We have solution A. Solution A has 1 gram of sodium hydroxide in 100 milliliters of solution. Okay, 1 gram of sodium hydroxide in 100 milliliters of solution. Solution B has 10 grams of sodium hydroxide in 100 milliliters of solution. Which solution is more concentrated? B. Why? Because B has more solute in the same amount of solvent. Right? So it's easy to compare the two because the two have the same amount of solvent. But I'll give you a different solution now. I will give you solution C. Solution C has 20 grams of sodium hydroxide, but in 200 milliliters of solution. So if we compare C and B, they would be the same, right? So C has 2 times the solute, but also 2 times the solvent. So a lot of people know, maybe have the experience of making juice from a can that is frozen. We have like orange juice you can buy in a can, and um, it's usually cheaper than the orange juice that comes in the big jugs because the orange juice that comes in a can has a lower mass and we can ship more of them, whereas the one that comes in the jug has a higher mass. So the deal is the juice that comes in a can is concentrated, right? And you have to add water to it in order for it to be drinkable, right? Otherwise, if you don't add water, it's too sweet and the flavor is too strong. So um, if you make 1 can of juice, you add 4 cans of water or 3 cans of water sometimes. It depends on the juice. So 1 can of juice will say 3 cans of water, right? But if you have a really big container, maybe you can make 2 cans of juice, in which case you would add 6 cans of water. So if we double the cans of juice, we double the water that it goes into, and it ends up being the same strength. We've just scaled up the recipe, right? So something that has 2 times the solute and 2 times the solvent is going to be the same concentration. So, in conclusion, concentration depends on two things. It depends on the amount of solute and the amount of solvent. Here it says the concentration of solution can be expressed in a variety of ways. We have one way that we use in the laboratory, in science laboratories, and we use the units moles per liter. So we find out how many moles are in our solute, and we find out how many liters are in our solvent, right? So moles, we have moles of solute, and we have liters of solvent. Okay, so our concentration, is going to take a variety of forms today, but our concentration is always measured as solute over solvent. So we have this formula for how we calculate these things in the lab, and it's C for concentration equals N for moles of solute over V, which is volume of the solution, of the final solution. Okay, so expressing concentration as the ratio of moles of solute to volume of solution is called the molar concentration. Okay, and sometimes this is abbreviated as M, right? So the molar concentration is sometimes in moles per liter, but sometimes you'll see it as M, which stands for molarity or molar concentration. So uh, the first practice question we have says, determine the concentration right? So they're asking us to find C of a solution of sodium hydroxide where 2 moles, right? That is our solute is dissolved to form 2.5 liters of sodium hydroxide solution. So this is our V. Okay, so what we're going to do is just to the side, we're going to set this up so that we know how to substitute numbers into our equation. We don't know C. N is 2.0 moles, and V is 2.5 liters, right? And you want to double check to make sure that your solute is in moles and your volume is in liters. If not, we are going to have to convert them. So then we write our formula, C equals N over V, and then we substitute in. So N is, sorry, we'll do it correctly. N is 2.0 moles, and V is 2.5 liters. So when we put that into our calculator, 2.0 divided by 2.5 is 0.8 moles per liter, or 0.8, sometimes you'll see M. Oh, hold on one second. We've made a mistake. 2.0 and 2.5 are to two significant digits. So we should write 0.80 moles per liter or 0.80 m. Now, the only problem with this is that we do not have devices to measure moles in the lab, right? We only have those balances that can measure grams. So if we're trying to make 2.5 liters of a 2.0 mole solution, we would have to convert the moles to grams, right? So if we wanted to make the solution, we would have to weigh the sodium hydroxide, right? So how much sodium hydroxide is 2 moles? We would have to multiply by the molar mass, right? So we would use this equation, except we would rearrange it so that we are finding out the mass. Right? So we would need to first find out the molar mass of sodium hydroxide because we don't have it. Sodium is 22.99 moles per liter, or not moles per liter, grams per mole. 22.99 grams per mole. Oh, what am I doing? Plus, that's not the only thing in sodium hydroxide, plus 16.00 grams per mole for water, plus 1.01 grams per mole for hydrogen. And if I add those together, I'm going to get, let's see, 40.00 grams per mole. And then we would multiply 2.0 grams, or sorry, moles times 40.00 grams per mole. And then the moles unit cancels out and we would get 80 grams. So to make this solution, we would need 80 grams. Don't need that third decimal. 80 grams of sodium hydroxide, right? This is what we would actually make the solution with in the lab. Okay. So sometimes we need to do an extra step. Let's try another example. It says, determine the mass of sodium chloride, right? Sodium chloride is NaCl, needed to prepare 250 milliliters. This is our volume. Milliliters is the volume. And of a 1.5 moles per liter solution. This is our concentration. Okay, so we are given a volume, which is 250 milliliters, which is not in liters, right? So we need to convert this to liters. And we are given a concentration, which will give us 1.5, or sorry, that is 1.5 moles per liter, right? And we can, with both of these, determine the moles, and then we can find the molar mass, and then find the mass. Okay, so our let's do our conversions. So the volume is in the wrong unit. We need to convert it to liters. And Milli, remember, means 1,000 times smaller. So 250 milliliters, if we multiply it by the conversion factor, where 1 liter equals 1,000 milliliters, we're going to get 0.250 liters. Okay, so now we can use that amount in the equation. Our moles, we're going to find out our molar mass. Sodium chloride, 22.99 plus 35.45, right? We're looking these things up on the periodic table. That is going to equal, sorry, trying to figure out what I did with my calculator. Okay, 22.99 plus 35.45 gives me 58.44 grams per mole. Okay, so 2 steps here. Number 1, we are going to use the C equals N over V formula to find N. That's our moles. Okay, we need to do some rearranging though. So we're not finding C. So we can arrange this formula to be N equals C times V. I hope that makes sense. And then we can replace concentration with 1.5 moles per liter. And we can replace the volume with 0.250 liters. And you see how this one is per liter, right? That means it's on the bottom of a fraction. So let me change the way I write this because I want to show you that the units cancel out. Right? This is moles per liter. Okay, so our liters cancel out and we're left with moles. 1.5 times 0.250 gives us 0.375 moles. Okay, and then we can use the M equals N times big M formula to find the mass. So M equals whoops. N times M, right, equals, so our moles is 0.375. We multiply it by the molar mass, which is 58.44 grams per mole. And I've run out of room. Okay, hold on one second. We're gonna make everything just a little bit tighter so we can fit everything in. N equals C times V equals 1.5 moles per liter times 0.250 liters equals 0.375 0.375 moles. To use M equals N times big M to find mass. So M equals N times M, which is 0.375 moles times 58.44 grams per mole equals 21.915 grams, but we're going to convert it to 2 sig figs. So we're going to convert it to probably 22 grams because we have this number here and it only has 2 sig figs. So my answer should only have 2 sig figs. Okay. Now it says in our lab, or the lab that I used to have with children in high schools, we will be using 100 milliliters of a 0.50 mole per liter sodium hydroxide solution. Determine the mass of sodium hydroxide required to prepare the solution. So this is a volume. This is a concentration. I'm using my units to tell me what letter it goes with, right? So volume is liters and milliliters. Concentration is moles per liter. And then it says determine the mass. That's going to be in grams of NaOH required to prepare this solution. So, so mass is lowercase m. So we have C, which is 0.50 moles per liter. That's in the correct unit. So I don't have to convert that. Volume is in 100 milliliters, so I have to use the conversion factor to put it in liters. Okay, making sure we're gonna say this is exactly 100 mils, so we're gonna make the decimal point there. Okay, so we're gonna make sure that this has 3 sig figs here. Our moles, we need to use our formula to get. Our mass, we need to use our formula to get. And our molar mass, we can figure that out right away. We have the formula for sodium hydroxide. So we have 1 sodium, which is 22.99 grams per mole, plus 1 oxygen, which is 16 grams per mole, plus 1 hydrogen, which is 1.01 grams per mole, and 0.00 grams per mole. Okay, so the first thing we're going to do is find the moles, right? And we're using N equals C times V. So moles equals concentration, 0.50 moles per liter times V, which is 0.100 liters, right? And the reason why we needed to put it in liters is, of course, so the liters cancel out when we multiply. And so we are going to get N equals 0.05. How many sig figs are we going to need? We're going to need 2. 0.50 moles. Okay, Step 2, we're going to find the mass using m equals lowercase n times uppercase M. So m equals, right, we just found n, 0.050 moles times 40.00 grams per mole. So you can see that my moles will cancel out and I'll have grams left. How many grams? Let me find out. 0.05 times 40.00 gives me 2 grams. So my calculator just says 2, right? But calculators don't know about significant figures. So I'm looking at the numbers given to me, and I can see that my concentration has 2 significant digits. So I'm going to make sure to turn my mass not just from 2 grams, but 2.0 grams, right? Meaning I should measure it to at least 1 decimal place on the scale, right? So therefore, we need a mass of 2.0 grams of sodium hydroxide to make 100 mils of a 0.50 moles per liter sodium hydroxide solution. So believe it or not, it probably makes sense that when I was in high school, I worked in a chemistry lab. I had a co-op in a chemistry lab, and eventually I turned it into a job at a chemistry lab. But the first day I was there, they actually asked me to make a sodium hydroxide solution. And I had to do these calculations. So they said, make me uh, this many moles and this many milliliters of sodium hydroxide solution. Here's a pencil, here's a piece of paper. The chemicals are in the closet over there. And I had to do it, and they tested it. And thank goodness I took grade 11 university chemistry so I could work it out. Okay. And this is what I did. These are the steps for preparing a solution if you ever have to prepare a solution. Number one, you have to do your calculations. So in this scenario, we wanted to make 100. So this is 100 milliliters of a 0.5 moles per liter copper copper sulfate pentahydrate solution. So the first thing that you do is you find the number of moles of copper sulfate pentahydrate that you need, right? And that was the same as the step that we just did. And the second thing you do is you find the mass of the copper sulfate you need, right? So this is the molar mass. You need to calculate that first, right? So they didn't show the calculation where they came up with the molar mass of copper sulfate pentahydrate. Maybe they looked it up online. I'm not sure. So then you go to your scale. This is a weigh boat. It's a little plastic dish that you spoon your chemicals into. And we want to make sure that the scale reading for this is 12.49 grams, right? So we weigh our copper, we go find the bottle of copper sulfate pentahydrate, and we scoop it into this little dish on the electronic balance. We would need to tare this first, or another word for tare is zero, the scale. Zero the scale first, just like you use a scale at home, right? Maybe you use a scale in your kitchen for cooking or a scale in your bathroom for monitoring your weight, you know that that scale has to read 0 before you put anything on it. Otherwise, you won't get a good measurement. Okay. So after we have our amount of chemical, what we're going to do is we're going to get out this. This is a beaker and a stirring rod, and we'll put 50 mils, half of the amount that we want to use of our solvent in, and we're going to put all of our solvent in, and we're going to stir it up. So we're going to pre-mix it, and then we're going to transfer it into a volumetric flask, right? This is an instrument that we use to make solutions in. It's only got one line, right? So you just have to watch that one line. We'll pour it into a funnel to make sure that uh, all of our solute and solvent make it into the container. We'll pour it against a rod so that there's no straining. And then, so here we have 50 mils, and we just want to rinse down the sides with distilled water, right? So we'll rinse down the funnel and the sides with distilled water. So all of what we poured in there goes in there. And then we're going to fill to the line. And using a dropper to make sure we get it as close to the line as possible. And then we're just going to mix. So you put a little stopper on the top and you fill to the line, and then you just turn it upside down a bunch of times until everything is mixed up really good. And that's how we would make a solution. So you have on the next couple of pages a little practice so you can get comfortable with finding the mass you need to make a solution.